Okay, I'm Luigi Sedda. I'm a senior lecturer in the Lancaster Ecology Epidemiology Group at Lancaster University. My work is mostly on optimization of surveillance of vectors, so essentially mosquitoes in Africa. So helping communities, government to make a surveillance plan for the mosquitoes. And for CLIMOS, I am an external advisory board where I'm very interested on the method they use, the quantitative methods that they are using. My impression on CLIMOS is that it's a very exciting consortium itself for the structure. I particularly like the synergy between businesses and academia, and this is, I think, is working well internally in each work package, but also between work packages which represent different scopes for the project. And I can see also the excitement in all the members of the consortium, which for someone coming externally from outside is a very nice environment. And the other things that I particularly like is the novelty of the work, because what they are trying to achieve, especially with the early warning system, is important for Leishmania, but I think it can be a very good product that can be used for also other vector-borne diseases, which in Europe are spreading. For example, West Nile virus is now going everywhere in Europe, and probably will reach UK at some point as well. Yeah, I think it can be used by, the most important ones is public health managers, because at the moment there is no such information on European level about the abundance of sandflies in the seasons, which can put people at risk, of course, and not only people, also animals. So public health managers can use this because there is no other information they can reach. Yes, there are the CDC's maps, but they are a bit static, and it doesn't represent the complexity actually of the sandflies dynamics that actually are real and very localized in Europe. The other one is academics like me, because sometimes when you need to do work, you need to catch sandflies. Catching sandflies is notoriously very difficult. Having a system that can tell us the probability that there are sandflies in one location respect to the other, so that in one location you may have higher probability than others. That can be very useful if I want to catch them, want to study the population, etc. And also for surveillance, of course. There is no much work around mapping sandflies or sandflies as individual species. And then the other element that is very important is to associate the abundances, densities, or how fit is a sandfly population with the disease itself in dogs, humans. So it is a very important work, and even if it's years and years study, there is still a lot to do. The early warning system is designed at the end to have maps of the distribution and densities of the sandflies in the different parts of Europe. And this is very important again, because it's an information that doesn't have the quality necessary to be used at the moment, and also is the starting point for any other interventions. If you want to surveil Leishmania in dogs, in humans, you need to have maps. It's the basic information. The other thing is very interesting as well is trying to understand the different the different capacity to transmit the parasite from each individual species of sandflies, because it can be species more dangerous, others less dangerous, so what we usually call primary or secondary vectors. And again, this can tailor any intervention that people can do. And again, it's also interesting to have an idea, and trapping for this reason is essential in any work with vector-borne diseases, because it don't give you only the information about the presence of a species, but also the relationship between species, because in some places one is dominant, the other not. And also the relationship with the rest of species, if we are lucky to catch, like culex or mosquitoes, other mosquitoes. So there is a lot of information we can take, and all the information is important to try to understand how sandflies distribute, how interact with the rest of the environment, or with the rest of the living species that co-occur with sandflies. In CLIMOS, the use of modeling is pretty advanced. There is a use of machine learning. It's very interesting. Machine learning informed by biologists, because they don't want probably to leave just the model running itself, assuming itself parameters or coefficients or elements that they want to put there. There are innovative elements, also the use of environmental, ecological data is pretty robust. And again, as I said before, I like the inclusion, so the recognition inclusion of the spatial, so the geographic element in the models, but at the same time also the seasonal element, because it's very important, understanding that the seasonality is not always when you have a peak of sandflies that translate directly in a peak of diseases. There are usually some lags that needed to be understood in order, again, to design tailored and effective interventions. The impact I expect from CLIMOS is a tool that can inform public health managers, that can prioritize interventions in areas where sandflies can boost, especially for the most important, epidemiologically important species, both for human and animals. So I don't say it's a first step, because actually it's quite a first advanced step, but is a step that go towards to the, we hope, elimination of the disease at some point, because Leishmania is still a neglected tropical disease, but should not be neglected because of the amount of humans affected by the disease. And in some areas, I'm not talking about Europe, there is a social stigma about also cutaneous leishmaniasis. It is important, should not be neglected by definition. So I think the impact can be massive, especially from management and control, surveillance of the disease.